Okay, so we'll wait maybe 3 more minutes. If anyone joins, we'll begin. If not, we'll begin. Actually, now that I think about it, we might as well just start while waiting. Okay, uh, since it's a bit of a heavy lesson. Okay, so welcome to our third lesson for IT 01 Information Technology and IT Ethics. Today we're going to do the last part of the information technology parts before we move on to the ethics part in our next lesson. Okay, so we're going to do app layout demonstrations. Okay, this is going to be covering assessment criteria 1.4, where we have to create and present presentations that demonstrate an application layout using planning tools. Okay, how do we communicate what our app is going to look like to stakeholders? Okay, could be investors, could be clients, could be users, could be the team even, right? When you're before you develop, you need to make sure everyone knows what are we making. So last week, last week we collected this requirement specification, right? We created a specification of requirements on how the app, uh, what the app needs to do, right? So then you and the team need to plan uh, what, now that we know what the app needs to do, how is it going to carry out those tasks? Okay, so that's where this comes in. This is where you demonstrate. Hey, Bobby, no problem. We just started. Okay, so we're going to do assessment criteria 1.4. Okay, so what exactly are we doing today? Okay, we're not going to be using PowerPoint or Google Slides, or like we're not making presentations, right? In the traditional sense, we're doing the next step of our requirement specification. Okay, so last week we ended off with 3 ways that we can specify requirements, right? We've already collected requirements. Now, how can we specify? How can we show what the requirements are? So we had 3 methods, right? The first was natural language, right? You just, in English or in whatever language that you want to communicate in, you say or you write out what the requirements are. Okay. Uh, this is the easiest. You don't need any technical skills. Anyone who understands the language will read it and know what you're talking about. Problem is, it's subject to interpretation, right? Anything that you don't specify, people are going to assume. Uh, they're going to make their own assumptions for it. Then the next one was diagrams. Okay, diagrams. I had shown you an example, and we're going to look mainly at diagrams in this lesson. Okay, it does need some level of technical knowledge, right? If you have no idea what the diagram is doing, how to read the diagram, you won't know what it's describing. Okay, some of them they're quite easy to guess. Okay, so for diagrams, you would use tools like Visual Paradigm. Okay, this used to be, it used to have a community edition which was free to use, but uh, I tried downloading it again. I don't think it's free anymore. Okay, but they do have a free online tool. Okay, so there's Visual Paradigm and there's Draw.io. Okay, we'll look at both. And then you have formal notations. Okay, something like this, which is extremely technical, but it's also the most specific. Uh, but again, when your purpose is to present to other people, you need to make sure they understand what you're doing, right? So natural language or diagrams is going to be your go-to. Okay, so when we're going to make our diagrams, we're going to use a use case driven approach, okay, to organize the system requirements. Okay, use cases, if you recall from last week, are the different functionalities that a system is supposed to have, right? The library should allow you to browse the catalog. The library should allow you to add new resources, right? Those are use cases. Okay. Uh, Use cases are step-by-step descriptions of an actor. Actor is any user. Okay. Could be an admin, could be end user. Description of an actor using the system to complete a process. Okay. So someone doing something is a use case. Okay. Step-by-step description of that. So we start off with our very first diagram, which is going to be the activity diagram. Okay. The activity diagram is a unified modeling language diagram, okay, a UML diagram. And activity diagrams document the workflow of a business process, okay? It gives you an overall view of how things are going to play out, okay? So you have a starting point, which is the black dot, and you have an end point, which is the eye, okay? So for example, if you have a university application system, okay, you start off and someone fills up the enrollment form. Okay. Did they fill it up correctly? If no, then they try again. Okay. If yes, then they get enrolled in the university. If they keep, if they enroll, if they fill up the form incorrectly, okay, if it's minor mistakes, then that's fine. You can still enroll. If they keep making mistakes, right, they keep trying to fill again, there is help available. So they can get help to fill out the forms. They fill up the forms and then they enroll in the university. Okay. And then it moves on to the next step. Okay. So this bar shows you uh, two things that can happen. Okay. In this one, even though the flow branches off, right, you have incorrect and you have correct, only one of these can take place at a time. Okay. Uh, it's basically a decision that is being, well, it's not a decision. The student doesn't decide which one they do. Okay. But over here, they get to choose. Okay. So they either attend the university overview presentation and then the activity ends, or they enroll in seminars and make tuition payment, and then the activity ends. Okay, so that's a basic university enrollment activity diagram. Okay, and then over here with another example of a librarian. Okay, we're going to look at this system a lot. Okay, a library management system. Okay, so you start off with the librarian buying a new resource item. Okay, and then we see, is this the first copy of the resource? Okay, a resource could be a book, could be a DVD, could be anything that's in the library, basically. Okay, is it the first copy? If it's the first copy, we record it as a new resource. Okay, and then move on to the next step. If it's not a first copy, then we move on to the next step, which is to record the resource item. Okay, record that we have a copy of it now. Okay, whether it was new or whether it was old, we have to update the system to show that we got a new copy. Okay, and then put it on the shelf to be borrowed. Okay, so okay, let me show you how you would do this with visual paradigm or draw.io. Okay, so let me get a new tab. Okay, if you want to use visual paradigm, okay, they have an online drawing too. Okay, I think it's VP online. Okay, they've changed the URL as well. Okay, visual paradigm online. Okay, let it load. Okay, so let's make a diagram. Okay, see if I can find activity there. Activity diagram. Okay, so here they have a few templates that you can look at, or you can just start from scratch by clicking create. Okay, so let's look at the template. Okay, so you have a starting point, and then you have all the activities, right? All the different steps that happen. Okay, so starting point, uh, and then we'll have an activity which is in oval shaped, well, a rounded rectangle, right? And then buy new resources, right? And then you have a decision node where one of two things happens. Okay, new resource or first copy, question mark. And then you connect the two by dragging. When you hover over an item, it shows up these arrows. You just drag down. Hover, click, drag. Okay, so a decision node will have two outcomes. Okay, so we will have uh, not the first copy. So this one will be no. Okay, and then we will have another. Okay, we're doing the librarian one, so it's not going to be. So if it's the first copy, then record new resource. Okay, first copy, yes, record new resource. Otherwise, they're both going to lead to the same decision. Let me see if I can find the connecting node. Can't seem to find it here. Oh, join node. Okay, this is the one. Let's widen it. Let's shorten it. Okay, so then they both lead to the same outcome. So we just connect it here. No. And this will be no and oh. Okay. If you don't like the way the triangles are bending, you can just drag them around. Not triangles, the arrows. Okay. There. Okay. Drag it down a little. And then you resume, right? And then the next thing, and then the next thing, right? And then the activity ends. Okay? Drag, drag, drag. Okay, so that's how you make an activity diagram on visual paradigm. Okay, oh, there's another thing called swim lanes. Okay, swim lanes, which are basically these rectangles. You can have them horizontal or you can have them vertical. Okay, what they do is they separate different actors. Okay, different actors. So for example, good lord. Okay, so you can put certain activities in certain lanes of the swim lane. I have no idea why this is so Lunky. Okay. Uh, so for example, this will be the librarian. So these are things that the librarian does. Okay. Maybe instead of ending the activity here, let me send this to the back. Order send to back. It disappeared. Okay. Maybe instead of ending the activity here, it moves to the next step, which is student borrowing the resource. Okay. Let's try taking a look at. Oh, this is what it looks like. Yeah, let's look at one of the templates instead. Okay, so you have a customer who inserts a card into an ATM machine. This is okay. This is a system for an ATM machine. Okay, an activity diagram for an ATM machine. The customer starts the activity by inserting the card, entering the PIN. Okay, then the flow goes to the bank. The bank is the one that authorizes their card. Okay, and then a decision is made. Was the PIN valid or was it invalid? Okay, if it was invalid, you eject the card, the customer takes the card, the activity ends. Okay. But if it was a valid PIN, the customer enters the amount, right? Amount they want to withdraw. Okay. And then the bank checks whether that's a valid amount, right? Does the person even have that much money in their account? Okay. If the balance is less than the amount that they're trying to take, basically they don't have enough money. Okay. You show them how much they have and then eject the card. Okay. If they have enough money, okay, you they can either enter money into the oh, okay, no. So if they have enough money, two things happen. Okay. The bank records how much money was taken out, and the customer takes money. Okay, they physically take out the money. Okay, and then they join together. The customer or the ATM machine shows the balance and then ejects the card. Okay, the customer takes the card and the activity ends. Okay, so that's how you use swim lanes. Okay, you separate what different people are going to do. So now you know that the customer doesn't do any of these actions. The ATM only shows balance and ejects the card. Okay. And then the bank does all the authorization and back end work basically. Okay. So that's swim lanes and activity diagram. And just for the sake of it, I'll show you what draw.io looks like. Okay, this is dark mode. Let me switch it to light mode. Uh, okay, no, and we'll leave it as is. Okay, so this is draw.io. Okay, in this one, it's not as organized as Visual Paradigm. Okay, but it does have the same resources still. Okay, so for example, activity starts with uh, a blank circle, right? So we can use this. Okay, maybe increase the size a bit. Okay, can't seem to increase. Or you could just add a normal circle, okay, and fill it black. Okay, fill black. Oh, okay, it's already filled. It's just I'm in dark mode, so you can see. Okay, and then use rounded rectangles. Okay, rounded rectangles. Okay, maybe make this smaller. And then in here you type uh, insert card. Okay, and so on. Okay, And then when you want a fork, okay, when the path splits, okay, you can just add a rectangle that's short but wide, okay, and another arrow, right, and so on, okay. So that's visual paradigm, okay. uh I can't recall why, but I preferred using visual paradigm. I preferred using draw.io over visual paradigm, okay. But it's up to you which one you want to use. Okay, so that's an activity diagram. Okay, next we have use case diagrams. This one we saw last week. Okay, use cases document functional requirements of the system, right? So librarian should be able to do this, 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 this. Student should be able to do this, 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 this. Okay, and then you have extend and include uh, arrows. Okay, and include arrow means that this thing needs to happen for this thing too. Okay, so when a student records loan, okay, when they're trying to borrow a book, they this is the action that they take. Okay, they record the loan, they try to record the loan, but the system will include this action automatically. Okay, so the student doesn't have to be the one checking the reservation, they're just trying to borrow a book. But when they're borrowing a book, the system will check the reservation status, okay, for them. Okay, so if I try to record a book, is the book already borrowed? That's what it's trying to find out, okay? Then the extend action is optional steps, okay? Uh, you can either reserve a resource directly or you can browse the catalog and then reserve resources, okay. But the arrow is opposite of what you think it would be, okay. This is something that I struggled to uh to understand, okay. Just so you know, which way should the extend arrow face in use case, okay, toward the base case, okay. So there's the extended case and then there's the base case, okay. The base case is the thing that they can what is it called, the base case is the starting point, okay. You can browse a catalog and then you can reserve resources, okay. That's why it's a base case. But the arrow comes from the extended case because this one is the final step, but you can do it through browsing also, okay. You can either directly reserve a resource or you can do it by first browsing, okay. That's where the arrow points, okay. So yeah, so just quick demonstration. I think we'll stick to, I think since this visual paradigm, I think is quite user friendly for uh, new users, because if you go to diagram, you can easily search up what you need, right? And they have templates. So maybe we'll keep using this, and I'll quickly show how it looks in that as well. Okay. So again, you have all these examples. Okay, or you can start blank. Let's just use an example. Okay, let's use one that has extend and include. These are all include. Can't see any extend actions. Okay, but these ones are quite basic. They just straight away point. Okay. Okay. So in a use case diagram, you still have overall rectangle. This time, instead of referring to different actors, it refers to the system. Okay, so this is a ride-hailing system. You have two actors. I'm guessing one is a driver, one is this one is a customer, this one is a driver. Okay, let's update that. Customer, driver. Okay, so in the ride-hailing system, a customer can request a ride. Okay, when a customer requests a ride, it includes the action of a driver accepting the ride. Okay, and when a ride is accepted, the ride starts. When a ride starts, eventually the ride ends. Okay, this action, the start ride, can't happen without accept ride request first. You can't accept a ride request if someone hasn't requested a ride. That's what include means. Okay, customer can cancel a ride, it can view ride details, it can rate the driver, it can update the profile and view drive. Okay, the customer can't view driver ratings. Okay, but the driver can view their own ratings. Okay, I think the customer should be able to do this. Okay, so let's edit this so that the customer can also view driver ratings. Okay, uh, actually, maybe they shouldn't be able to because uh, the driver rating could be under ride details. Okay, because each ride has a driver, and the driver rating could be included in ride details. Okay, so this is up for you and your team to discuss, right? Should the customer be able to separately search driver ratings, or should it be under ride details? Okay, just for the sake of it, if you do want to add an arrow, right? How do you change the style? Okay, so let's hover. Let's drag it here. Okay, now it's asking me what kind of arrow I want. Okay, do I want a dependency? A dependency is this kind of arrow, right? The include arrow. Do I want realization? Okay, we're not discussing this. Or do I want association? We want association. Okay, we want a solid black line. Okay, and then over here, you can see what type of line you want. Okay, you have the different types. Okay, so you can have a curve, but we want straight. Okay, we want a straight line. Let's connect it here instead so it doesn't overlap with the other lines. Okay, yeah. Okay, sometimes your system is going to be so complicated that you just can't avoid crisscrossing lines. Okay, you'll have lines that cross one another. In such cases, you can have there should be a feature to basically bounce the line. Okay, I don't think Visual Paradigm has it, but draw.io does. Okay, so let's quickly actually I think I can copy paste this. Control A, Control C, Control V. Nope. Copy as image. Oh, I can only paste images. Never mind. Okay, so let's say we have one user, another user, and use case uses ovals. Okay, okay, and then each is connected to one of these. Let's make this straight line and set it as the default style so that every time we drag, it's straight line. Okay, and we also don't want the end to be an arrow. We just want it solid. Solid. Set as default style. Okay, so now whenever we drag, it's going to be a straight line with no arrow. Okay, so let's just say that these things have to cross. Okay, there's other things around here that make it so that these things have to cross. Okay, uh, yeah. Okay, so how do you make sure that people don't get confused by crisscrossing lines? Okay, one might be understandable, but when you have many, it becomes a bit confusing. Okay, so first thing you should try to do is not have crisscrossing lines. Okay, try to reorganize the things so they don't crisscross. Okay, of course you should also try to make sure that related activities stay together. Let me see if I can show you my university project. Okay, quick just a quick search in my Google Drive, because I remember that that was a big problem for all the students who were doing our final year project. Uh, Everyone had crisscrossing lines. Okay. Let's see. It should be under undergraduate project, assessment items, figures, and no, it's not here. Different module. Give me a quick second. Figures. In the meantime, does anyone have any questions so far? Okay, so within no questions, great. Okay. Um, it's taking some time. Okay. 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 So this was my. Why is it so corrupt? Okay. So this was my use case diagram. Okay. It was a hotel reservation system called Book for Me. Okay. And yeah, a lot of use cases. Okay. Uh, we needed to have extend actions, we needed to have include actions, so we couldn't simplify our diagrams. We had to take every single thing into account. Okay. Why was I showing you this? Oh, crisscrossing lines. Okay. Crisscrossing lines. So when we would crisscross, right, I tried to regroup as I regrouped the use cases like 4 or 5 times, and I just couldn't avoid crisscross lines. Okay. So for example, if you look here, the lines are overlapping, but I've made it bounce. Okay, there's a line bounce so that when it overlaps, you know that, okay, this line goes this way and this line goes straight. Okay, so that's how you can make it easy to differentiate between these lines. Okay, the way to do that is you select one of these lines, and then you should have an option called line jumps. Okay, select that, and then you have different types of jumps. Okay, you have a line option. Okay, let me zoom in so you can clearly see what that looks like. Okay, there's this, don't really like it. There's sharp, don't really like it. There's gap, don't really like it. There's arc, this is the one that I like best. Okay, and you can choose the size of the arc. Okay, by default it's 6 points. Okay, and that's how you don't get overlaps. Okay, so then if you were to get another okay, so if this one overlaps, again you need to assign which one is going to be jumping. Okay, but if I, let's say, add a line here, and this one now crosses this one, see, it jumps again. Okay, if this one also crosses it, now it jumps both lines. Okay, right. So that's the use case diagram. Okay, so here we have some use cases, and after you make your use case diagram, the next step is to expand on what each of these use cases are. Okay, you don't want to leave anything up to interpretation, you have to specify. Okay, so first you make a high level use case diagram. Okay, so for each use case that we had in the diagram just now, you specify who is the actor, right? Who can carry out this action, and what what is this action? Okay, so record new resource item. This use case begins when the librarian wants to record a new resource item. If it's the first copy, new resource will be recorded whether it's a book or a DVD. So now we know what a resource item is. Okay, it's either a book or a DVD. Okay, um, yeah. Okay. Um, and then you expand. Okay, how exactly does it do what you put in the description, right? Check reservation status. Actor is librarian. Okay, when the librarian wants to check if there is a reservation on a resource, okay, librarian enters the title of the resource and the reservation status is returned. Okay, so now we know this is how you check the reservation status. Okay, so you expand on this in an expanded use case diagram. Okay, we call it a diagram, but it's technically just a table. You don't need special tools for this. You can just do it in Microsoft Word. Okay, so it goes into more detailed on a high level use case. So it's called an expanded use case because it expands on a high level use case. You can also call it a detailed use case diagram. Okay, so it gives you a deeper understanding of the functional requirement. Okay, so what's the use case? What is the goal? Right, to record a new resource. Who is the actors, librarian, and when does this system? When does this use case begin? Okay, when a new resource item is acquired. Okay, one that isn't already in the system. Okay, so that's the trigger for this. Okay, so when you have the events, okay, what happens in this activity? There's two things that will happen. First is the actor action. So in this case, it's the librarian, what the librarian does, and how the system responds. Okay, so it starts with the actor. Okay, it almost always starts with the actor. Okay, this use case begins when the librarian wants to record a new resource item. Okay, so what do? They record the title of the resource, okay? And the system checks if this is the first copy, okay? Uh, Up here, you do the best case scenario, okay? It's not the first copy or the most detailed scenario. So ideally, you want it to be this use case is for when it's not the first, when it is the first copy. Sorry, okay? When it is the first copy and it needs to be recorded, okay? So system checks. If it is the first copy, the librarian records the date acquired of the resource item, and the system will create a barcode and set the status to available. Okay, so these are things that the system developers would want to know, right? What happens? What should the user be able to do? How should the system respond? Okay, and the number of copies is increased by one. Okay, and then you also have alternative course of events. Okay, so in line two here, line two, librarian records the title of a book. System response checks if it's the first copy. If it's the first copy of a book, these are what you need to record. If it's the first copy of a DVD, these are what you need to record. Okay? And then line four, uh, date acquired of the same resource. If there are additional copies of the same resource, repeat line four. Okay, so you record the date again and again for the same resource. Okay, and each time the number will increase by one. Okay, so now the system developer would know which actions need to be taken. Okay, how exactly does this use case work? Okay, uh, so we move next to classes and objects. Okay, an object is an instance of a class. Okay, so classes are basically templates. Okay, just now we looked at resources, right? A resource can be a book or a DVD. Okay, but then you have many types of DVDs, you have many types of books, right? Different books have different titles. So the class would be the book. Okay, you have a book, but then you have many books, each with different titles, different authors. So each of those is a different instance of the book class. Okay, so you'll have, for example, the resource class. Okay, you'll have the name of the class. In this case, it's resource, and then the class has attributes. Okay, different properties for this class. Okay, so a resource has title, it has date of release, and it has number of copies in the system. Okay, and then each class also has operations, so you can add resources, and you can check availability for resources. Okay, so that's your classes and objects. Then different classes have associations. Okay, associations are used to represent relationships between classes. Okay, how do these two relate to one another? In this case, a resource object describes a resource item. Okay, this is the meaning of this is what the relationship is. Okay, so you have a resource, and then you have different resource items. Okay, this is what you can borrow. Okay, you don't borrow resource, you borrow resource items. Okay, next you have inheritance. Okay, inheritance comes into play when you have two classes that have very similar attributes. Okay, so for example, in our system, students can borrow resources. Okay, but then resources, there are two types. You have books and you have DVDs. Okay, types, that's the word you're looking for. Okay, types. So there's a general class, which is resource, and then there's specialized class. You have a specific type of resource, which is called a book. You have a specific type of resource, which is called a DVD. Okay, so that's generalization, specialization. A book is a special kind of resource with additional attributes. Okay, so this inherits all the properties of a resource. Okay, so a book will have a title, it will have date of release, it will have number of copies. You can add a book, you can check a book's availability. Same thing for a DVD. It has title, date, number of copies, it can add, it can check. Okay, but a book also has a publisher, an author, and an edition. Okay, whereas a DVD, it doesn't have these things, but it has its own things: producer, format, and rating. Okay, yeah. Okay, so let's look at how students will borrow a resource item. Okay, they check the library system to search for required resources. They can loan resource items represent their ID. Librarian checks students' details, check whether they owe any money for lost items, record barcode, resource item, inform the student when they are due to return. Okay, so let's enhance our activity diagram, okay, from our first slide, because now we have a bit better idea of what things are supposed to look like. Okay, search and borrow resource items. Okay, so here is where the swim lanes come in. Okay, the librarian can do all the actions that we looked at earlier, and the student can start the activity by browsing resource items. Okay, uh, is the resource item available? Yes, then they get to uh, the library to borrow it and take it from the counter, and their loan is recorded. Okay, if it's not available, then they can search for something else. Okay, so going back to class diagrams. Okay, class diagrams document the different classes in the system and how they relate to one another. Okay, so we looked at this portion of the diagram earlier, right? You have resources, and then you have special types of resources. Okay, and the thing that's actually borrowed is a resource item, right? So for example, for the Matrix DVD, right, that's a resource, but then you have many copies of the Matrix DVD. Okay, each of which can be borrowed separately, each of which was acquired on a different day. Okay, so that's why you have a resource and you have resource item. Okay, uh, all of these things are under the library. Okay, so one library, right, the library has a catalog of many resources. That's what the star means. Okay, one library, many resources. One resource, many copies. Okay, one item can be taken on many loans. Okay, And one student can take multiple loans. They can borrow multiple items. Okay. Uh, one resource can have one or more resource items. Okay. One resource can have one or more copies. Okay. That's what one dot dot star means. One or more. One to many. Okay. Any questions on class diagrams? Okay. Take that as a no. Okay. So we move on to system sequence diagrams, SSD. Okay, this is not the memory storage. This is system sequence diagram. So now that we know what the different use cases are supposed to do, the different steps, we need to see how the system and the users will communicate. Okay, so the system sequence diagram gives an overview of how a, an actor interacts with the system. Okay, so for example, if a librarian wants to add resources, okay, add a new resource, okay, they find the resource by searching up the title. The system returns the resource. Okay, uh, if it's the first copy, okay, they add a new resource by recording the title, date release, author, publisher, edition, and they get a confirmation message. Okay. Uh, if it's a DVD, they instead add these things and they get a confirmation message. Okay. And then they record the date acquired. Okay. So in an SSD diagram, you have the actor, okay, with a solid line underneath them. You have the system with a solid line underneath them, okay, and then you have messages that pass between the two. The message from a librarian to the system would be an input message, okay. You enter information into the system. So you record input messages with a solid line, okay, and you number them. Uh, the system responding is a return message, okay, return values. Those are recorded with dotted items, okay. So when you're writing out the messages, okay, how do you write that? Okay, what are the SSD notations? So if you have any conditions, okay, you record them in square brackets, okay? Is it a new book? Is it a new DVD? Okay, that's in square brackets. And then what are you going to get in return? Okay, when I do this, I want to get the resource in return. Okay, so that's what you write next. And then colon equals, and then what the message name is. In this case, we're adding book, we're adding DVD, we're adding resource items. Okay, and then what information are you passing along? Okay, so this diagram, when it's properly edited, becomes this diagram. Okay, because in this case we're not recording the conditions, right? We're just numbering and naming the function. Okay, then you can also have frames. Okay, frames frames can be used to further clarify logic, okay? Because one thing that we have to remember about this use case of the librarian recording a new resource is that they only record a new resource if it's not already in the system, right? But the current diagram doesn't show that, right? You find a resource and then you record add book, add DVD, add resource item, right? It doesn't show you that. So that's where frames come in. Okay, it's basically a big rectangle to clarify. Okay, if resource is not found, then you add a book or add a DVD. Okay, everything making sense so far? Great. Okay. And then you have operation contracts. Okay. Contracts specify what the system must do when a system event occurs and an operation is initiated. Okay, so it basically defines system behavior, right? When a new object is made, when you change the attribute values, when you create relationships between different classes. Okay, so for example, this is the template for operation contracts. But for example, if we're finding a resource, okay, these are the different functions that we described just now in the system diagram, right? So here we have four operations, right? We have find resource, we have add book, we have add DVD, and we have add resource items. Okay, so we still don't know how exactly these will work, right? So this is where we define it. Okay, so find resource title. Okay, find resource title. For this operation, we're trying to find a resource given the title. Okay, so easy to understand. The resource object must exist. Okay, when we're searching it, the resource must exist for you to be able to search it, which means that if it doesn't exist, you'll get an error. Okay, and then after we search, if we found it, we'll return that object. Okay, the resource, whether it's a book or a DVD, is found based on the title. Okay, so the name is the operation name of the operation. That's simple. Responsibilities is why. What is this operation going to do? Okay, precondition is assumption before the execution. Okay, precondition in this case is we assume that the object exists. Okay, and then what happens after the action is carried out. Okay, so every action that you have in the SSD, in the system sequence diagram, you for every action you need to have an operation contract. Okay, so we did one for find resource. Now we do one for add book. Okay, with these parameters to create a new book, the book object must not exist. Okay, you only add a new book if the book doesn't already exist. Okay, so the book is created, the attributes are set, and the book is linked to the library. Okay, that's what happens. Okay, uh, add DVD, similar thing, right? To create a new DVD, the DVD must not already exist. It's created, attributes are set, and it's linked. Okay, and then add resource item. Okay, uh, to add a resource item, the resource object must already exist, right? So if it's a book, the book must exist. If it's a DVD, the DVD must exist. Okay? So if it exists, right? If the preconditions are true, the resource item object is created, the date acquired is set, the barcode is generated, it's set to available, and it's linked to the resource. Okay, whether that's a book or a DVD. Okay, and number of copies of that resource is increased by 1. Okay, so now we know how the system is supposed to behave, right? We know what each actor can do, we know how they do those things. Okay, but we still don't have a visual of how these things will look, right? Where does the librarian enter all the details? What do they click? What do they look at, right? So that's where interface designs come in, okay? So interface designs visualize what the software is going to look like, okay? There's many tools to do this. You have things like Pencil. Pencil is very, it's for making mockups, okay? You don't have colors or anything. It's just squares and rectangles. You have Figma. This is the most popular one because you can add images, uh, you can add some sort of interaction into it. You can add like swipe actions and everything. Okay, and then Adobe XD, of course, this is paid, so can't really do that. Okay, I have a link here for, I think this is a 1 or 2 hour course on how to use Figma. Okay, Figma is free. It has a software version. It also has a web version. So Yeah, you can use this if you want. Okay, but if it's too complicated, you can just use pencil. Okay, pencil is just a drag and drop tool, right? You have all the items here, and then you drag them down here. Okay, so those aren't all the diagrams that you have in requirement specification. Okay, you also have other diagrams. You have the domain layer sequence diagram. Okay, so in the system sequence diagram, we only discussed interactions between the actor and the system, right? Messages going forth between the two. But then how does the system itself do calculations? Okay, that's where the domain layer sequence diagram comes in. Okay, when the user searches uses the find resource type uh, action, what does the system do? When add resource type is carried out, what does the system do? Okay, so it's an expansion of the system sequence diagram to show how the system processes requests. Okay, internal communication within the system. Okay, so it shows how the different classes interact with each other to carry out operations. Then you also have the view layer sequence diagram. Okay, the view layer sequence diagram shows which windows open up when the uh, when the actor does specific actions. Okay, at different points of a use case operation. So, for example, add resource type, when the school admin clicks the add resource type button, this window pops up. Okay, and it shows you this information. And then this button is clicked, and it shows you this thing, and then these operations are carried out. Okay, but that's maybe for a more advanced level in the future. Okay, for now you just need to know activity diagram, use case diagram, class diagram, and system sequence diagram, and then of course interface designs. Okay, any questions? No questions, no questions. Okay. Before we end, uh, just an announcement. Our final lesson was supposed to be on 23rd, right? Next Friday is supposed to be our final lesson. Okay. I'm not able to conduct the lesson on that day, so we're going to reschedule it to the 28th. Okay, it's going to be rescheduled to the next Wednesday. I'll send a message in the group as well, just as a reminder. But next week, so we're going to have a class this Friday, and then next Wednesday, and then the Wednesday after. Okay, so next Friday, no class. Okay, is that fine with everyone? Great. Okay, so if everything is fine, then we'll end here. Thank you everyone for coming. And I'll see you guys on Friday. Bye.